Hello class, welcome back from your break. I hope that it went relatively well considering the circumstances. Today we're going to talk about the independent samples t-test. The independent samples t-test is typically used when we have a between subjects design, meaning that we're comparing one group to another group and each person has been observed at one time or at one level of a factor. One example of when we might do that would be if we wanted to compare men and women. That would be a quasi-experimental design because we didn't get to randomly assign individuals to groups or anything. And we could then make a comparison on men and women and whether men are more aggressive than women as an example. If we wanted to do that, our hypothesis could be that men and women are different, and we could state that as men and women are not equal, or we could say that men minus women would not be equal to 0. Both of those would convey the same information. If we wanted to be more specific though, and we thought not only are men and women going to be different, but we think that men are going to have higher aggression than women, we could say that men are going to be greater than women on average, or we could say that the average for men minus the average for women should be greater than 0, because if men have a larger, higher number on aggression, whatever that score means, then we would expect that their difference would be greater than 0. When we perform this test, there are a few assumptions involved. The first one is the assumption of normality. And we've talked about this before. It should be that the distribution for men and the distribution for women is relatively normal. And in particular, what this does is it gives us information about the error, because our best prediction for a man is the average for men if we don't know any other information, which in this model, in this type of test, we don't. The only thing that we know is the one independent variable, which is gender. And then the best estimate, the best guess for a woman would be their average. And so as women are higher than average or lower than average, that is error in this model because that is variability that we cannot explain. So really, more specifically, it's unexplained variability. And in the case of this model, that is error. That is something that we can't predict from this model. We also should have a random sample of women and a random sample of men. Each individual should be independent. So all of the men, with the exception of the fact that they are men, should be independent from each other. This might get violated if, for instance, we went and we measured individuals right after football practice. One, if you're familiar with aggression, we know that increases in testosterone, which often follow kind of aggressive behavior, lead to further increases in aggression, and they tend to have kind of a reciprocal relationship. So it's possible that if we caught them right after practice, then maybe their rates of aggression have increased through that practice. But additionally, we have the selection bias. Just by their choice to be on the football team, it's possible that they are more or maybe even less aggressive than the average man, and thus we don't have independence in that case if we went and we measured the whole football team. Now, if the football team was the individuals of interest and we wanted to compare them to another sample, then perhaps that's useful because that's a target sample, but we wouldn't want to just collect from them to represent men more broadly. And then last, and this part is new, we also have an assumption of equal variances or homogeneity of variance, meaning that the variability between men and women should be relatively equal. And a rough estimate for that is we can compare the variance of whichever group is larger, so numerically whichever variance happens to be larger, divided by the smaller variance, and as long as that is less than 2, we probably haven't violated that assumption. There are more formal tests, called Levene's test for instance, that can check that homogeneity of variance assumption, and we'll talk more about that when we get into ANOVA, which also has this same assumption, and we'll talk about how to check that. When we do this test, there are a couple of formulas that are involved. The first, for T obtained, is going to be the difference between X bar for group 1, X bar for group 2. So in the case of comparing men to women, we could have X bar for men, X bar for women, and compare those two averages. And then you would subtract the expected difference. Most of the time that expected difference is going to be 0. Similar to whenever we were doing the dependent samples t-test, typically the difference that we expected was 0, and we were seeing, is our difference something other than that, something different from 0? Now, if we had, again, some prior treatment and we wanted to see, is this new treatment more effective than the previous treatment, we could use something other than 0 for that comparison, but that is the one that we would start with typically. We are then going to divide that difference by the standard error of the mean, and in this case the standard error of the mean is going to involve a pooled error term that incorporates variance from group 1 and variance for group 2. We divide both of those variances by the number of individuals in each of those samples, add them together, and then take the square root of that in order to get the standard error of the mean. You can simplify this formula if the n's are equal, for instance, but rather than learning 2 formulas, I'm just going to teach you this one, because this one will work if the n's are equal. It will also work if your n's happen to be different. For effect size, you can do Cohen's d, and it's probably covered in your book. Another measure of effect size that's often used for independent samples t is eta squared. And for eta squared, you're going to take t squared and you're going to divide by t squared plus the degrees of freedom. So similar to Cohen's d, what we're really doing is trying to remove the impact of n. And so by adding degrees of freedom, which is based on n, that then helps us to account for the number of individuals, to account for the sample size. Degrees of freedom in this case is going to actually be n1 minus 1 plus n2 minus 1, and we can think about that as big N, the total number of participants across both groups, minus 2. This is consistent with what we saw before. When we did a dependent samples t-test, for instance, it was the number of differences minus 1, because we had to calculate one mean, the mean of the difference scores. In this case, we lose a degree of freedom for each mean that we have to calculate or estimate, and so we have to estimate the mean for group 1 and the mean for group 2. Because of that, we lose 2 degrees of freedom. The last formula that you need to know is the confidence interval. So this formula, similar to what we saw before, this is giving us the confidence interval of the difference. So we take the difference between the mean for group 1 and the mean for group 2, and then for the upper limit, we're going to add t obtained times the standard error of the mean, and for the lower limit, we're going to subtract t obtained times the standard error of the mean. As we've seen before, if you have a negative t obtained because you're doing a one-tell or directional test, what you would do in that case is you would just take the absolute value of t obtained, so you don't have to worry about flipping your signs or anything like that. And so if you just use the absolute value so that it's always basically positive, then this formula will work where if you add, it's the upper limit, and if you subtract, it's the lower limit. In addition to watching this brief video, the next thing, kind of like I would do in class, is you need to go in and practice. There is an assignment listed under the in-class practice folder, and so if you go under there, you'll see an assignment for the independent samples t-test, and then we'll make the answers available to that. I know it's really tempting, given this new class situation, to maybe just skip to the answers. Hopefully we're far along enough in the semester that you understand that it really is important. A lot of the times when I go over it, it feels like, hey, I know that, hey, this is easy. And when you actually have to go in, work through it, then you go, wait, I didn't quite understand that as well as I thought. And so I really do need you to try to do the in-class practice the same way that you would do it if I was standing and looking over your shoulder, and then look at the answers. The good news is you can go at your own pace. Shoot me an email if you have questions. Feel free, if you want to do a screenshot or video yourself and send me that. If you need to send me a video, you could always use Dropbox, OneDrive, Box. I have all those accounts, so feel free to use any of those. And you can just upload the video to one of those file sharing accounts and then send me the link so that I can look at the video of what you're trying to do and why is it maybe not working.